Dear friends, welcome to this one more video lecture in which we are talking about the resistors when connected in series and parallel. In the previous lecture, we have seen what do you mean by the resistor and what's its use in an electrical circuit. A resistor is a device which has the property of a resistance. It opposes the flow of current in the electrical circuit. If number of resistors are connected in series, what will be the equivalent resistance? That we have to see. A resistor is connected in series. The resistors are said to be connected in series if they are connected in such a way that the resistors are connected one another after and the one end of the first resistor is connected to a source of electrical energy, that is the battery, and the other end of the last resistor, which is connected in series, is connected to negative of the battery. Let us consider it's a simple circuit in which I got three resistances of R1, R2, R3 be the resistance of the three resistors connected in series. In series combination of resistors, the current flowing through each of the resistor will be the same and there will be the branching of potential difference. रेजिस्टर्स कनेक्टेड इन सिरीज कधी म्हणायचं की रेजिस्टर्स एकानंतर एक कनेक्ट केले जातात, वन आफ्टर द अनदर, in such a way that current through each of the resistors will be the same. Here battery positive is connected to end A and battery negative is connected to the end B. And here these are the points between A and P. There is a resistance R1 between A and Q. There is a resistance R2 between Q and B. There is a resistor R3. As battery positive is connected to A is at higher potential and some amount of work is done in order to flow a current through a resistance R1. Therefore, there will be fall of potential at point B. Therefore, the potential at P is less than that of the A, and the potential difference between A and P, let it is equal to V1. The potential difference across R1 is V1. Again, as compared to Q, P is at higher potential. Current flows through R2 and some work is done in order to flow of current through R2, and because of that work done, there will be fall of potential, and potential at Q is less than at that of the P. Therefore, potential difference between P and Q, let it is equal to V2. In a similar manner, whenever current passes through R3, there will be a fall of potential, and potential difference or the potential across R3 is V3. In series combination, current flowing through each of the resistor is same and there is fall of potential across each of the resistor. The total potential difference across the combination, let it is equal to V. Therefore, there is branching of potential across the resistance, and this total potential difference V is equal to potential difference across V1 plus potential difference across R2 plus potential difference across R3. By Ohm's law, the potential difference is the product of current and resistance, and therefore I will write it as I into R is equal to I into R1 plus I into R2 plus I into R3. If I take I into R is equal to I in the bracket R1 plus R2 plus R3, I get cancelled. Therefore, equivalent resistance in series is equal to sum of the resistors connected in series. सेरीज कॉम्बिनेशन मध्ये लक्षात काय ठेवायचं आहे की रेजिस्टन्सेस एकानंतर एक कनेक्ट केले जातात, व्होल्टेजचं ब्रँचिंग होतं, करंट प्रत्येकातून सारखा वाहतो आणि सिरीज कॉम्बिनेशन मध्ये सगळ्या रेजिस्टन्सेस मिळून सगळ्या रेजिस्टन्सेसची बेरीज होते आणि आपल्याला तो इक्विव्हॅलंट रेजिस्टन्स मिळतो. आणि म्हणून आपण असं म्हणू शकतो इन सिरीज कॉम्बिनेशन द इक्विव्हॅलंट रेजिस्टन्स is more than the individual resistance. Here it is more than the highest of all. Series combination चा उपयोगच रेजिस्टन्स वाढवण्यासाठी होतो. Algebraic sum of all resistances in series is equal to the equivalent resistance. If there are three resistances, one is of 2 ohm, other is of 4 ohm, and third one is of 6 ohm, then the equivalent resistance is equal to 2 plus 4 plus 6, it is equal to 12 ohm. This equivalent resistance in series combination is more than that of the highest of all. सगळ्यात मोठं कोण आहे? 6. त्याच्यापेक्षा सुद्धा याची किंमत जास्त असते. This is all about what is the equivalent resistance when the resistances are connected in series. आताच आपण असं पाहिलं की रेजिस्टन्सेस एकानंतर एक कनेक्ट केले आणि त्या सगळ्यातून करंट सारखा व्हायला तर पोटेन्शियल डिफरन्सचं ब्रँचिंग होतं आणि त्याला ते सिरीज मध्ये असं म्हणतो. सिरीज मध्ये सगळ्या रेजिस्टन्सेसची बेरीज होते आणि इक्विव्हॅलंट रेजिस्टन्स मिळतो. आता आपल्याला पॅरलल कॉम्बिनेशन ऑफ रेजिस्टन्सेस मध्ये काय होतं पाहूया. मुळात रेजिस्टन्सेस पॅरलल कॉम्बिनेशन मध्ये कनेक्ट झाले असं का असं मग कधी म्हणायचं? इफ नंबर ऑफ रेजिस्टर्स आर कनेक्टेड इन बिटवीन 2 पॉइंट्स, this is one resistance R1, this will be the other resistors of resistance R2, this will be a third resistor of resistance R3. All the three resistors are connected in between 2 points A and B. And a source of EMF battery is connected across the ends A and B. Then this combination of resistors are said to be connected in parallel. In parallel combination of resistors, the potential difference across each of the resistor will be the same because the resistors are connected across the two same points A and B. Battery positive is connected to A, battery negative is connected to B. Therefore, potential difference across A and B will be same as that of potential difference across R1 potential difference across R2 and potential difference across R3. In parallel combination of resistors, potential difference across each of the resistor will be same, but there will be a branching of current in the circuit. Let this is the current I delivered by the cell. The current through R1 is I1, current through I2, R2 is I2, current through R3 is I3. Obviously, the potential difference across each of the resistor will be the same. It means that the current through a resistor of higher value of resistance will be the less. Potential difference सगळ्याच्या अक्रॉस सेम आहे आणि V इज इक्वल टू IR आहे. तर काय होतं की ज्याचा रेजिस्टन्स जास्त आहे त्याच्यातला करंट कमी आहे. कारण प्रोडक्ट ऑफ I into R, that potential difference voltage will be the same across each of the resistor असं म्हणतोय. तर ज्याचा रेजिस्टर जास्त आहे त्याचा करंट कमी आहे. तर हे ब्रँचिंग कसं होतं, जो रेजिस्टर ज्याच्या रेजिस्टन्सची किंमत जास्त आहे त्याच्यातून वाहणारा करंट कमी आहे आणि ज्या रेजिस्टरच्या रेजिस्टन्सची किंमत कमी आहे त्याच्यातून वाहणारा करंट जास्त आहे. लाईक दॅट देयर विल बी अ ब्रँचिंग ऑफ रेजिस्टर करंट. The total current that flows through the circuit I is equal to sum of the currents in each of the resistor. Therefore, I is equal to I1 plus I2 plus I3. The potential difference across each of the resistor will be the same. Therefore, I is equal to V divided by R. Now, it will be the potential is same. It is V divided by R1, V divided by R2 plus V divided by R3. Therefore, V divided by equivalent resistors in a parallel combination, equivalent resistance in a parallel combination RP is equal to V in the bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. This V get cancelled from both sides of the equation, and therefore at last we will get this RP will be, 1 upon RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If there are n number of resistors connected in parallel, then it will be plus 1 upon R4 plus 1 upon R5 plus 1 upon Rn, so on and so forth. Now, reciprocal of equivalent resistance is equal to sum of the reciprocal of each resistor, each resistance, and hence the equivalent resistance is smaller than the smallest of all resistances connected in parallel. मित्रांनो, एवढं लक्षात ठेवायचं की इक्विव्हॅलंट रेजिस्टन्सचा रेसिप्रोकल हा प्रत्येक रेजिस्टन्सच्या रेसिप्रोकलच्या बेरजे इतका असतो. म्हणून इक्विव्हॅलंट रेजिस्टन्स सर्किटमध्ये असलेल्या सगळ्यात लहान रेजिस्टन्स पेक्षाही कमी असतो. Therefore, the parallel combination of resistances is used in order to reduce the value of resistance in the circuit so that current in the circuit increases. जिथे कुठे तुम्हाला रेजिस्टन्स कमी करण्याचा प्रश्न असतो तिथे तुम्हाला पॅरलल कॉम्बिनेशन रेजिस्टन्सचं वापरायचं. लहानात लहान त्याच्यापेक्षा इक्विव्हॅलंट रेजिस्टन्स कमी असतो. आपण याचं एक छान एक्झाम्पल घेऊया. लेट अस कन्सिडर R1 is 2 ohm, R2 is 4 ohm and R3 is 6 ohm. In that case, the equivalent resistance 1 upon RP is equal to 1 upon 2 plus 1 upon 4 plus 1 upon 6. It should be equal to LCM is 12. That is 6 plus 3 plus 2. Therefore, it comes out to be equal to 11 by 12. Therefore, what RP is equal to? RP is equal to 12 upon 11. This value is little more than that of the one. little more than that of the but it is not more than that of the two. Therefore, the value of equivalent resistance is less than the smallest one. In short, what you have to remember here is that when resistances are connected one after the another so that current through each of the resistance will be the same, then it is a series combination. In series combination, equivalent resistance is algebraic sum of resistances connected in series. In parallel combination, resistances are connected in such a way that the potential difference across each of the resistance will be the same, and there is a branching of current. The resistances are connected across the two same points, then the reciprocal of equivalent resistance is equal to sum of reciprocal of each resistance connected in parallel, and this combination is used to reduce the value of resistance in the circuit in order to increase the current. Like this, in this video lecture, just we have seen what is the equivalent resistance when they are connected in series and what is the equivalent resistance when resistors are connected in parallel. And this is all about the series and parallel combination of resistances in the electrical circuit and how they are useful that we have seen here. Thank you very much. Please subscribe, share and like my videos. Thanks once again.